This lesson is graphs of polynomials, and our learning target is I can find key features of graphs. A lot of this is going to be review, and then there's going to be a few new things at the very end. Okay, so we've already talked about this year, but just in case you've forgotten, a constant graph is going to be f of x equals some number. So it's just going to be a straight line. So like this graph would be y equals 4. A linear graph is going to be like a diagonal line, and that's going to be f of x equals x. A quadratic is your U-shaped graph, so anything that has an x squared in it. A cubic is going to be x to the third, and it looks a little weird, something like that. A quartic is going to be x to the fourth, and it looks pretty much like a quadratic. And then a quintic is the last one, and it's going to be x to the fifth, and it looks pretty much like a cubic. And then they all kind of start to repeat after that. Okay. Another thing we've talked about is in behavior, but we're going to review it again, make sure we understand it. So go ahead and graph that function in green and sketch you a little graph. So remember, it doesn't really matter what's going on in the middle of the graph, you're looking at the ends. Okay, so notice that the left end is definitely going up, and then the right end is definitely going up. And then there's some weird notation. So if you want to say the left side of the graph, you would say as x approaches negative infinity. And because it's going up, we're going to say it goes to positive infinity. If you want to talk about the right side of the graph, that's when you say as x approaches positive infinity, f of x is going to infinity because it's going up. If it's going down, it's going to be negative infinity. Alright, go ahead and sketch a graph of this one. Alright, so just focus on what the ends are doing. The left end is definitely going down. The right end is also going down. So if you want to say the left side, you say as x approaches negative infinity. And because it's going down, we're going to say f of x goes to negative infinity. Negative infinity means down. This one over here, if you want to say the right side of the graph, you say as x approaches positive infinity. And then you're going to tell it what f of x is doing. It's going down, so it's going to negative infinity. Alright, go ahead and sketch a graph of this one. And you can try this one if you want to. You can pause the video. Just focus on the left side. The left side is going up. The right side is going down. Left means as x approaches negative infinity, because it's going up, we're going to say f of x goes to positive infinity. When you want to say right side, you say as x approaches infinity, f of x is going down, so it approaches negative infinity. Alright, go ahead and try this one. Sketch it and see if you can fill it in. So pause the video in 1, 2, 3. Alright, the left side is definitely going down, so we're going to say it goes to negative infinity. The right side is going up, so we're going to say it goes to positive infinity. And that's how you do the end behavior. So that should be review. And now we're going to talk about some different terms. Okay, so in previous math courses, especially when you were doing quadratics, you talked about the vertex, and you talked about finding the maximum or minimum. Alright, so if you look at this graph, it's actually going to continue going down on the left side forever, and up on the right side forever. So it doesn't actually have a maximum or minimum, but it has a relative maximum or a relative minimum. And these are where the turning points are. So think about if you're going up this graph, you're going up, 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 and then right here you start to turn and you go down. Right here you start to turn and you go back up. So turning points are where the polynomial function switches direction. And another word for this is called extrema. Sometimes they say extrema, but it sounds like they're saying excrement, so it sounds like poop, and I don't say that. So I call it extrema. But the one in blue that's highlighted here, this would be a relative max because it's a turning point and it's like an upper turning point. So you're like at the top of a hill. So at the top of a hill would be a relative max. This one here in green, that is our relative min. So you can think about a relative min being like, I don't know, the bottom of a hill, a cliff, something like that. It's really just the turning points. If you're an upper turning point, you're a relative max. If you're a lower turning point, you're a relative min. You can have multiple of these. So you could have a graph that just turns a lot. It just depends on what you're given. Okay. So on the right side, if you want to use Desmos to find these, it's super easy. All you gotta do is graph it and then click where you want them. And then if you look on the left side, this is a review from Math 1 and Math 2, how you find a maximum or a minimum. Okay, so either using a calculator or using Desmos, go ahead and graph these and see if you can read the instructions to find the maximum or minimum. And pause the video in 1, 2, 3. Okay, so I did it in Desmos because I think it's super easy. So in Desmos, all you gotta do, type the function in, and then you just click. So here's the relative max. Alright, and then right here is your relative min. And it's super easy. If you did it in the calculator, your decimals may be just a little bit rounded, but you still get the same idea. Okay. So now let's look at, this is a pretty popular question that you'll see sometimes. So if you think about using a sheet of paper, like just a regular sheet of printer paper. So it's 11 and a half by 8. Okay? And you're going to cut away 4 square corners. Okay? And then you're going to fold up the remaining flaps. So here's kind of what your box is going to look like. It's going to be an open top box. Alright, so imagine taking a piece of paper, and if you have one at home, you're more than welcome to cut away 4 square corners, fold up the sides, tape them together, and you'll have this little open top box that we do. And what we're trying to do is we're trying to figure out what's the maximum volume an open top box could be. So if we were in the classroom, this will be a fun day because we would actually do it, and then I would fill your box up with popcorn, and whoever has the biggest volume gets the most popcorn, and we would talk about that. But it's virtual, so I'm sorry. So let's talk about some things from like previous math courses. If you want to find volume of a box, volume is equal to length times width times height. So let's think about this for a minute. We started out with a width that was 8, and then we took away this much and this much. So we don't know how much we took away, so we're going to use x's. So we took away 2 x's. And then we had 11.5, and we took away this much and this much. And we don't know how much that was. We just cut some square corners. So let's look at it this way. So we have 8 minus 2x, 11 minus 2x. And then if you think about the height of that box, it was determined by the corner. So by x. The height of the box is going to be x. Okay, so volume is going to be, my length was 11 minus 2x. I'm sorry, 11.5. My height was 8 minus 2x. I'm speaking out of turn again, sorry. So this is my length, this is my width, and the height of the box was x. So what I want you to do is I want you to graph this function, all of it, in Desmos right now. And then we're going to look at it together. So graph it in Desmos, draw your little picture, screenshot it, whatever you got to do. Okay, so your picture should be like this. I had to zoom out a little bit just to see it. So let's think about what we wrote. So we had 11.25 minus 2x. I said it wrong again. 11.5 minus 2x. 8 minus 2x. And then times x. So that was our length, our width, and our height. That's how you find volume of a box. So x is how much the corner was. So the corner we cut away. And then y is the volume of our box. So when you look at the relative max, this is your x. So the corner we cut away, if we had cut a corner that was 1.548 inches, then the maximum volume we could have got is 63.798. So if you wanted to have the most popcorn in your box, you would need to cut a square corner of 1.548 inches, and you would have had a volume of 63.798 inches cubed. Okay, so using this reasoning, I want you to try the discussion post, and this time you're going to use a different piece of paper. And I want you to write out and show your work as much as you can. If you want to take a screenshot of what you put in Desmos, that's showing your work. Or if you just want to type it out, that's also showing your work. Let me know if you have any questions. Okay, bye.